Okay, so I'm just going to do a couple more of those long division polynomial divisions using the rectangle method on exercise 1307. So here's some examples from your book. This is 1a, x squared plus 7x plus 4 divided by x plus 2. So start off by setting up our little chart, and we have across the bottom there, we put the sum, and you can see that I draw this line on the right hand side of this last term, okay, because this is always a given. So to start off, I'm going to write in red so you can see what I'm doing. We start off, this is a given term, x squared. Great, already got one down. Now I have to say x times what gives me x squared? X. So I can put that straight up the top. And I take the x and I multiply it by 2, and I have here, down here, 2x. It's my first column, done. Next, I can see now that I have 2x, but I want to have a total of 7x. So I have to put in this spot over here 5x, so that I get my total of 7x. So this is 5x. Now I want to divide 5x by x, so that up the top now I'm going to have 5 plus 5. Great. Now I can multiply that 5 by 2, I get 10. Now I want my units to be 4. So I have a 10. What do I need so that I get 4? I need minus 6. Now x doesn't go into minus 6, so this becomes my remainder. So when I write my answer at the end, I'm going to have an answer written as x plus 2 is one factor, and then what I have across the top, x plus 5, but I also have this remainder of minus 6. That's the way they like you to write your answer. So it will be x plus 2 times x plus 5 with a remainder of minus 6. Done. Okay, let's do another one. This is a horrible question. It comes up with really horrible numbers. I think it's worth doing. So this, I think, is number 1G, and actually the answer in your book is slightly incorrect, so I'm going to fix it for you. So here we go. I put across the bottom my sum, and notice that this highest power of x is on the left of this bar here. So I'm going to start off. What do I need? 2x cubed is a given. There it is, straight away. Whoops, cubed. So I have to say 2x cubed divided by x gives me 2x squared. That's my first term. Now I've got to multiply that by 6. 6 2s are 12x squared. Great. So now I'm trying to find this number here. How many x squareds do I need so that my total becomes minus 1? That would have to be minus 13x squared. If it helps you, I'll draw a little bar here. Okay. So minus 13x squared divided by x is minus 13x. And then that times 6, this is where the numbers get yucky, is minus 78x. Now I want to get a total of plus 5x. So I have to put up here plus 83x, because 83x and minus 78 gives me 5. Awesome. Divide by x, I get plus 83. And then if I do 83 times 6, I end up with a horrible number, 498. But we want to have 3 units, so I would have to... there's the problem. Okay, so I want to have plus 3, which means I need to subtract minus 495. Whew, that was ugly. So if I go to my final answer now, I would write as x plus 6 times, my factors across the top, 2x squared minus 13x plus 83, and I have a remainder of minus 495. And actually that matches your answer in the book. Hallelujah. I'll skip that. Okay, now I've got a question from question 2a. It wants p of x divided by t of x, where p of x is this left-hand bracket and t of x is the right-hand bracket. So I set it up. There you go. So we've got our answer across the bottom, and our first one is a given, 3x squared. So now I'm going to find 3x squared divided by x, 3x, times minus 2, minus 6x, and I want to have minus 7x. So I need one more, minus x. So this goes up here. That divided by x is minus 1, and times minus 2 is plus 2, and I want to have plus 5, so I need another plus 3 here. But 3 doesn't go into x, so that's my remainder. So my answer I already have is x minus 2 times 3x minus 1 with a remainder of plus 3. Done.